This is paracetamol.
Sorry, can you hear me? Those online, can you hear me now? I'm good. Okay, I've done the introduction earlier, so I'll just do it again. Like I said earlier, my name is Alidayo Dukoya. Then I'll be taking you through introduction to machine learning, linear regression, in quotes. So I don't know. I'm trying to make this class as interactive as possible. So do you have any idea on what machine learning is? Maybe prior knowledge or anything? Yeah. Anyone? Okay. So take that as a no. So, machine learning is the ability of computers to identify patterns of past occurrence. Then they learn these patterns and use the patterns to make predictions for similar instances. That's so basically, machine learning is just you using what's it called computers to learn what has happened in the past and how it can use it to predict the future. So these are some of the concepts we'll be using going forward. Data. So data is any digital representation of events, occurrence, or information. So when you hear train, so it simply means the process of teaching a machine learning algorithm to identify patterns in a particular collection of data points. And features are a group of data points that are used to train the machine learning algorithm and label or target. So we use label or target interchangeably. So this is what the machine learning algorithm is trying to predict. Let's say you probably want the machine to predict if you'll be able to go to work tomorrow or not. So that feature being able to go to work tomorrow or not is what we call label and target or target rather. Okay, so we have different types of machine learning. I think we have four types of machine learning: the supervised, unsupervised, semi-supervised, and reinforcement learning. So, supervised learning is also known as inductive learning, which is training data includes desired outputs such as label or e.g. to detect if a message is spam or not. So this type of learning is supervised. Just like I explained earlier about you trying to determine if you'll be able to go to work tomorrow or not. So once you have a desired output in your data, so it simply means it is supervised machine learning. So unlike unsupervised machine learning, which does not include desired outputs. So in this case, you might just be trying to separate similar data. Maybe you have a pocket of data, and then you're trying to separate similar data sets or trying to make a pattern out of your data. So we have semi-supervised learning also, which the training data includes few desired outputs. That's partially supervised and partially unsupervised. Then we have reinforcement learning. So reinforcement learning works to optimize rewards or minimize penalties from a sequence of action. The algorithm tries to find the best action sequence to perform a task based on some constraints. So this is I'll just try to make this I'll try to relate this as possible. So take for instance you are trying to train a dog on how to relate with a dog. So definitely while you are training your dog rather, you'll be having you have your reward if your dog gets it right, and you have the reward if it doesn't. So reinforcement learning is just about you penalizing if your model is doing the wrong thing and you rewarding your model. So that way your model learns faster. Okay, so in supervised learning is a type of system in which both input and desired output are provided. So then under supervised learning we have classification. So a classification classifier is a type of model in which output variable, which is the label this time around, we can also call it targets, is discrete or finite or countable. So for example, to predict if a patient has cancer or not, or if an employee will leave or stay in an organization. So we have different types of classification model. We have the logistic regression, the decision trees, and the random forest. So basically in classification, why they say it's discrete is your target is always okay, there's finance here. So it's either you are doing this or not, or you have three options to go with. So you're always left with at least two decisions to make when you're talking about classification models. So under classification model we have logistic regression. So what you're looking at say it's an image of linear and nonlinear regression. So, but before we go into logistic regression, we'll just define regression basically. So we have a regression model is the type of model in which the output variable is continuous. That is, you you can predict the price of house in an area or how much rainfall will occur in an area. So we have different types of regression model. We have the linear regression and we have the decision trees. So under unsupervised learning, which is a type of learning in which the outcome variable, what we are looking for in the data set is a relationship between each data point. Like I said earlier, when you're talking about unsupervised learning, you're only trying to find pattern within the data. Like similar data comes to one side, while different data also go to another side. So two different types of we have two different types of unsupervised learning. That's clustering and association. So under clustering is an important concept when it comes to unsupervised learning, as it mainly deals with finding a structure or pattern in a collection of uncategorized data. So under clustering, we have three types of clustering model, which is the hierarchical clustering, k-means clustering, and KNN, which is the k nearest neighbor. So these are an example of k-means clustering. So you can see the data is just visualized here. Sorry, you can see the data here. After applying k-means clustering, data were able to group themselves into similar with data with similar properties or characteristics. Okay, so for association rules allows you to establish association amongst data objects inside large database. This unsupervised technique is about discovering interesting relationship between variables in large database. For example, people that buy new are most likely to buy new furniture. So basically, association is about you deciding on the data set on a feature based on a similar experience. No. Yeah. Okay. Okay. I'll use that example again. So if you're talking about association in that aspect, say you are coming to class, I might use the fact that you are coming to class to determine if your best friend will come to class. So that is not target. In targets, you are actually using your personal variable to determine if you come to class in supervised learning. So it's based on your previous experience. But yeah, I'm trying to determine if your friend will come to class because you come to class. So examples of association are a subgroup of A a subgroup of cancer patients grouped by their gene expression measurements. Groups of shoppers based on their browsing and purchasing history. Then movie groups by the rating given by the movie viewers. So these are just examples of association. Does not necessarily the data does not necessarily have to come from the particular observation. It has to relate with another that means when one occur, what's the probability that the other parts will occur in association? So, okay. Okay, sounds okay on my side. So semi-supervised, let me just get there. So semi-supervised includes few desired outputs. So what this means basically is under semi-supervised, you are trying to predict different things. So part of your prediction might be a supervised learning technique, while the other part of the prediction is unsupervised. Um, so I can't really think of a perfect example right now, but once I get one, I'll let you know. But we have supervised learning, unsupervised, and semi-supervised. And semi-supervised is a mix of both supervised and unsupervised. Okay, so we have machine learning process. So we have machine learning process. So machine learning process, it's just, I'll call it a pipeline for how your data from the moment you collect your data to the moment you get your data. I'm sorry, you get your model. So so we have different stages of process and different steps in machine learning process. Starting from the data collection to preparation, then you train your model, you analyze or you evaluate your model, you serve your model, and you retrain your model. So under data collection, these are the things we are doing basically. So under data collection, we are talking about what data exists. Like when you want to collect your data, these are the things you need to put into consideration. What data exists? Where can you get the data? Is it public or are there any privacy concerns? Then is the data structured or unstructured? So these are the three important factors you consider while collecting your data. So after you've collected your data, which is the data collection process has been completed, then you move on to your data preparation. So under data preparation, you start by visualizing the data, which is the exploratory data analysis, call it EDA. Then you move into the data pre-processing, which is you cleaning the data, trying to get the missing value and the outliers and the likes. Then you also split the data. So after splitting the data, um, okay, when you split the data, does anyone know why we split the data here? Yeah, yeah. So you split the data basically because you need a fraction of the data for you to test if your model is actually working right or not. So whenever you have your data, because you don't have the existing answer somewhere, so you have to split. It's just like you having the answer at the back of your textbook while you do your classwork. So you need to compare if your answer is right or not. Okay, then we move to training a model. So when you want to train a model, three factors are also considered. You choose an algorithm based on your problem data, then overfit, then you can regularize data, and you can also the hyperparameter. So once you've collected your data and you prepare your data, now you need to decide if your data falls under supervised, unsupervised, or semi-supervised, or reinforcement learning. So once you've determined that, you can now pick an algorithm based on this. Then fit the data, which is overfitting then regularizing the data. After that, you can also be hyperparameter to give you better model. So after this stage, you move to analysis and evaluation. So here's where you talk about the evaluation metrics, feature importance, training, training cost or inference cost, then worst examples. So after training your model, you can now evaluate the metrics of your model. If your model is actually performing well or not. Then from there, you can look at the feature importance. That is, you looking at the features in your model that are actually more important that you can give preference to, and you're going to remove the ones that are not needed. So then you can now check the training costs or the inference cost. Then you can also, while training your data or while analyzing your data, that's when you get the worst case scenario. You might not have thought about this while policing your data. So maybe when you're almost done, you realize that okay, this kind of situation can occur. So then that will take you back to you policing your data again just to improve the model. So you can now serve your model after analysis and evaluation, which is putting your model into production, and you can always reevaluate your model just to improve the model. Then after serving your model, you can now retrain the model, just like I explained earlier. If the old prediction still valid, why not? You can leave it. Then if it does not, you can always improve the model. Okay, just like I explained in this diagram, this is another diagram for machine learning process. So which is taking the data into preprocessing and learning, then the error analysis. So preprocessing includes normalization and dimension reduction. Learning can be supervised, unsupervised, or reinforcement learning. Then error analysis are precision called overfitting or test validation data. Okay, so linear regression is considered the most natural learning algorithm for modeling data. Why? Because one, it is easy to interpret and model efficiently for most natural problems. Two, it is a statistical model that examines the relationship between two or more variables, independent and independent variables. Three, a linear relationship basically means that when one or more independent variables increases or decrease, the dependent variable increase or decrease too. So this just states the relationship between independent variable and dependent variable in a linear relationship. So for it finds the line of correlation best fitting data point that can be used to predict the values of the dependent variable for some dependent variable and vice versa. So whenever you carry out linear regression, so some of the things you look out for is the correlation of the best fitting data points. So this just the mathematical representation of the linear regression is y equals a naught plus a 1x plus error. So where your y is your target variable or your dependent variable, your x is your independent variable, which is your predictor. That's what you're using to get your y. And your x can be as many as possible depending on the data set. Then your a naught is the intercept of the line, while your A1 is the linear regression coefficient, or then your epsilon is your random error. So if this line could extend up to across here, you're going to get your intercept on the y-axis. So that's the intercept we're talking about here. So your linear regression coefficient can also be calculated from the data. So this is just the same as y equals mx plus c. I believe you are familiar with y equals mx plus c. Yes. Yeah, equation of a straight line. So there are different types of correlation. We have the strong positive correlation. This is where if there is a change in your independent variables, if it affects your dependent variables strongly, you can see here, like, let's say, so this line is your x and this is your y. So whenever there is an increase in x, there's always a significant increase in y. And you can see this from the straight line because all the points are almost on the straight line. For weak positive correlation, the change in X will give just a slight change in Y. Like the changes are not really efficient, but there's a change. So you can see from here that the points around this line are not close to the line. So it's a weak positive correlation. So for strong negative correlation, in strong negative correlation, increase in X will cause a significant decrease in Y. So if there's any positive change in X, there'll be negative change in Y. And if there's any negative change in X, there'll be positive change in Y. Okay, we also have weak negative correlation also, just like I explained on weak positive correlation. Change in X will not significantly affect the change in Y, but it's going to be an inverse relationship. Increase in X will cause decrease in Y. So we also have moderate negative correlation. You can see the point around moderate negative correlation. They are not that close to the straight line, which is the line of best fit, but they are still closer than big negative. And then we have a situation where there is no correlation at all. This is where your data is just around your graph. You can't really make sense of it if it's going up or going down. So when working with linear regression, our main goal is to find the best fit line. That's where the error between the predicted value and actual value is most minimized. So the best fit line will have the least error. So okay, so this is an example of the best fit line. Some people call it line of best fits. So this is where you're trying to get the relationship between your data and your prediction, and you're trying to get the best fit line, which is the best line, the line that is sufficient for this data set to describe this data set or the relationship in this data. So linear regression predicts continuous value. Before a data set can be trained on a regression model, the label must be continuous variable and not discrete. So for linear regression, your label has to be a continuous variable and not discrete variable. So examples of your label, like I said, you can use targets or label. So examples of your label can be predicting salaries from years of experience. So how many of you can say he collects, oh, I collect just, or I take home 1 naira monthly, I take home 5 naira monthly. There's always a little bit of change on it. So this kind of change makes the data set continuous and not discrete. So you can see maybe you take home 5,600 or something there, or 7,000 something. So another example is determining glucose level from age of the patient. So whenever you are determining the glucose level, it's always a decimal point or something around that point. So you can also predict the student grade based on the total time study. So um, I believe you are familiar with student grades. You have the GPA 3 point something. So values like that are continuous values, and predicting the examination score based on student score. Okay, so we'll be moving to the practical part of this. So our case example will be our client okay, sorry. Our client is one of the biggest restaurants in Lagos, Nigeria, Mama T restaurant. So the objective of the regression task is to predict the amount of tip gratuity in Nigerian era given to food server based on the total bill, gender, smoker, whether they smoke in the party or not, day of the week, time of the day, whether for lunch or dinner, and the size of the party in Mama T restaurant. So basically, what we are trying to do here is to predict the amount of tip given. Whenever you go to restaurant or any eatery, whenever you go to any eatery, there is high chance of the security guard or the server there trying to ask you for tip or something. So you just have to private tip them, at least just a small change. So we are trying to predict the amount of tip that these servers will get based on the following feature or the following feature of the data, which is the total bill of the customer, the gender of the customer. So if the customer is a smoker or not, then the day of the week, which day of the week it is for the party, and time of the day, if it's either lunch or dinner, and the size of the party in Mama T restaurant. So the label for this data problem is the tip, which is the amount that we are trying to get. And if then we have six pictures in this data, like I explained earlier, which is the total bill, gender, smoke, date, time, and size. Do we have this data set? No. Okay, I think it should be shared after the class. So the first thing you do is to import your needed libraries. So you'll be importing NumPy as NP, import pandas as PDL. So you also need matplotlib, cborn, and pandas profile for profile reports. So once you've import your needed libraries, you can now import the data into the system, which you can do with this. Then from there, so once you have your data in the system, you need to know how your data looks like before you start preprocessing. So one of the steps on machine learning process is data collection. So this data has been collected already. So we are moving to the preprocessing stage now. So for you to preprocess this data, you need to know how your data looks like, at least have a brief idea of your data. So you can run the tick.add. So here you'll be seeing the first five observations of your data. So you can see the total view, which from here you can see this is a continuous data. Then the tip is also continuous, and the gender is discrete. You have either male or female, and you have the smoker, which is yes or no. And the day of the week is also discrete rather. So it runs from Sunday to Saturday. And you have the time if it's lunch or dinner, and you have the size of the meal. So after doing this, you need to know how many columns and how many rows you have, which is the tip.shape. Then from here, you can now describe your data. So from here, you can get the mean, the maximum, the third percentile, the first percentile, and also the number of observations in the data. So if I run profile reports now, Genesis, okay. So profile reports is just basically another type of description. But I don't want to get into this because we might not have enough time. So this is an error I will have to sort before we share the data, before we share the notebook. Okay, so these are just the first few lines of code that I ran is just for you to know, it's just for you to get used to your data set. So once you've gotten used to the data set, you can now proceed into the preprocessing part. So then the preprocessing part shows the relationship between the categorical variables. So the first one will be getting here, it's the relationship between the gender and the tip. It's not person. Yeah. Oh, sorry, sure. So this is meant to show the relationship between the gender and the tip. Can you kindly, thank you. Okay, I think this is a version compatibility issue. Okay, so this is actually meant to show you the relationship between the smokers and non-smokers, and tip rather, but this is a version compatibility issue. Finally, okay. Okay, so about the data sets mentioned, so you have to hold on for the data sets. We can still move on. So this is the relationship between the amount of tip and the gender. So can anyone just tell me what's going on here from what you can see? Is that okay? I outliers. Okay. So who else? So those online can also comment. Okay, when looking at this data, you can see that the male gender has more outlier than the female gender. So technically, the tip from the male gender might be more than the female gender. But all these are still observation from your visualization. You still need to know why this is going on. So you can also check for relationship between the smokers and the tip. So who can also tell me the relationship between the smokers and the tip? So this is non-smokers and these are smokers. We just look at the visualization box plots and just infer. Okay, so what you're looking at here, it's from the visualization, you can see that non-smokers actually give higher tips than smokers. So just because the range of this box plot is high and they have higher higher outliers aside for this particular observation. So the conclusion is they give almost the same amount of sleep, but you can see, yeah, it's almost, but still the non-smokers edge it a bit because this is higher than this, and it started from virtually same range. Okay, so after plotting the smokers and tip, you can also check the time and tip also. Then from here, you can see that they also those that take lunch also give almost the same amount of tip as dinner, but we have more outliers in those that take dinner. So after checking this and you are sure that you don't have any missing value from your description earlier while trying to get the data set here from your no? Somewhere around. Yeah, so from your described feature here, you have the total number of observations to be 744, which is actually confirmed here while checking the shape. So you are sure that there is no outlier. I'm sorry, there's no missing value. So you can go into training your model. So whenever you want to train your model, the first thing you need to import is your metrics, like the metrics library. So import the metrics library and also import the train test splits library. So the train test split library helps you split your data set into a desirable number. So you can split the data set into different ratio or desirable ratio. You can decide to use a larger percentage of the data set to train, which is actually ideal, and use a smaller percentage to test. So yeah, we'll be splitting the data into features and label. So since we are predicting the tips, so our tips automatically becomes the label or the target feature. So we need to separate the tip into a Y array, then also separate the rest of the features into X data frame. So just for you to get this X data frame, rather than you going into probably you have to import gender, amount, the other seven features, you just need to just drag the existing one from tip. So once you drop it, you have your X. So if you check your X head now, which is you just checking the overview of the head, you can see all the features that we need for us to create a model. So we have the total bill, gender, smoker, date, time, and size. Then if you check the Y head, you have all your tips in the Y head alone. Okay, so now we are still on the preprocessing because I think large chunk of the work is done under preprocessing. So once you get to your model, you just need to create your model. So after separating your X and Y, then you need to create one autoencode for all categorical features in the data because scikit-learn linear regression algorithm cannot work with categorical data directly. They require all input and output variables to be numeric. In this case, we create a one-hot encoding for gender, smoker, day, and time by using PD get dummies. So just like the way you have your computers that basically your computer cannot relate with your normal day-to-day conversation. It relates more under zeros and ones. So you need to convert all the data set that you have into a reasonable figure for the computer to be able to understand. So we'll be converting this gender column, which has male and female, the smoker, the day, time, and also the time. Okay, so before then we need to split data sets. Yeah. So once you've gotten your dummy, so this is basically one-hot encoding. So once you've gotten your dummy, so what this one-hot encoding does is to pick every each value in each feature and create a new feature with them. So for gender, remember that we have female and male under gender. So for gender, you have 0 and 1. So 0 for if you are not a female is 0. Then if you're a female it's 1. Then it creates another feature from the gender which is for male also. So if you're a male it's 1 on this column, and if you're a female it's 0. So you have the zeros and ones here for this particular observation or this person. Then also for smoker, you have either you're a smoker or not. So this column identifies smokers or non-smokers as 1 and smokers as 0. While this column identifies smokers as 1 and non-smokers as 0. So same thing happens to days of the week. So if you have a particular day of the week, the particular day of the week will take the value 1, while the rest will take 0. And also if you have the time, so the time, if it's either dinner or lunch, that's to take zeros and ones too. So then you can always check your shape just to make sure you're in order. So after this, you can split your data set feature into training and test data by using the train test split function from SQL. So the training sets here that we decided here will be 80%, while the test sets will be 20%. And also you need to set a random state. So the popular random states being set is always 42. I don't know why people decide to use 42. You can use any number of your choice. But once you use the number, make sure that whenever you are splitting your data set again, you need to set it into that particular number. So here we'll be using the random state as 42. We'll be using the random state as 42. So this is code for you to split your data into train and test. So you have the X train and X test, Y train and Y test into this. So you have your X data set and your Y data. Then the test size is 0.2. Like we said, yeah, we'll be using the large chunk of the data to train the data. Then we use the 0.2 to test. And also you have your random state to be 42. You can decide your random state to be any value, but whatever value you choose, whenever you are doing this again, for you to get the same result, make sure you use that same value. Okay. Um so here we are now going to import our model, our library model, which is the linear regression. So we are done with the pre-processing. So now our data is ready for us to create the model. So the first step, once you've import your library, which is our preferred library is linear regression, and we are using linear regression because this is a continuous data. So you need to instantiate your model. So when you instantiate your model, it means you are simply turning it on before you use it. So this is how to turn it on. So once you turn it on, then you can now fit your data sets, which you've already splitted earlier, into X train, Y train, X test, and Y test. So you can then fit after fitting, which is here. So technically, what your computer or your machine is doing here is to memorize or get used to the data set, like we explained earlier on supervised learning, in supervised learning. So after getting used to the data set, then you can now predict. So what you are doing under this prediction is to predict for X test. So why you are predicting for X test is just to compare whatever value you get with the existing value that you've splitted from your X train, Y train, X test, Y test. Then you can now visualize the first 10. So this might take a while. for oh wow, it's faster. This was going to take you wow. So these are the first 10 predictions for your tips. So you have 290 point something up to 295.3 blah blah blah. So now that you've gotten your predictions for your Y test here, sorry for your X test rather, it has been set under prediction as a variable. Then you can now compare your actual values, which is the actual the actual tip that the customer gave with the current prediction, just to know how well your model performs rather. So now for you to compare, you can create a data frame between the actual values and the prediction value. So you can also check the shape. So we have 149 observations and two columns. So the two columns are the prediction and the actual value. So here you're viewing the top 30 with dot head. So you can see from here the actual tip given is 436, but the prediction, our machine predicted 490 point something. Here we have 545, but it predicted 358 and the likes. Okay, so now that you've seen, now that you've been able to tabulate the actual values and the prediction, you can also compare the errors. So now to get your error, so this is the difference in the value between the actual value and the prediction. So the actual value here is still Y test. Don't be confused, it's still the same as this actual value. So for example, we have 436 here and 290 point something, which is on observation row 609. So you still have row 609, and this is the difference between them. Okay, so now you're moving into your evaluation because we've collated our data, we've preprocessed it, we've created a model. Now we are moving into evaluation. So my preferred evaluation metric is mean squared error. So this just compare the mean between or the error between the actual value and the predicted value. And it's also rounded up to three decimal places. So if I carry out the mean square error and the root mean square error now, so maybe the mean square error is 26,860.903 and the root mean square error is 163.893. Okay, so you can still print the maximum tip and the minimum tip here. So you have maybe on a bad day, you have some people that don't even give tip at all. That don't give tips at all. Then on their good day, when the stars align in their favor, we have up to over 1,000 error tip. Okay, so now that you've evaluated your model, you can see that your error is quite high. So what you just need to do is just to retrain the model now. And you keep on retraining till you get what's it called? Better error. So the lesser your error, the better your model. So if I have another model that gives me 150 something as a root mean squared error, I'm actually going to pick that model above this current one. Yeah, any question? Or is it all too much at once? So much to take in at once. Okay. So let me check the chat section if you have any question there. So you can also carry out your exercise too using the same data set. Please don't. Yeah, I think so. Yeah, to be sure. But in the meantime, you can always carry this out. Like, you can just use it to play now. Wow. Okay. Um, so I think you can get the data set from the classroom. So you can just go to the Google Classroom. Oh wow. Sorry. Okay. Why is the extension CSV? Why is it not? Okay, it's just why is it CSV? So that's because you are working with Excel. It's an Excel file. So the data set, the data set is stored in Excel file. So then we have different formats in Excel. So the easiest format for you, so it won't be that heavy CSV. Okay, so those online, if you also have any issue, just share with us. Okay, there are questions there. Oh, okay. The first question is from Toyib Jimon. Says after converting the categorical variables to dummy variables, do we need to remove any surplus column? Since a column usually shows, for instance, so since a column usually shows, for instance, one for yes and zero for no. So I think I get your question here. Yes, you can drop it. So actually, it helps your model. It improves your model. So once you know you have a column that shows for yes, automatically the zero under it is no. So you can drop the next column. So at first error value will we know that the model is at its optimum? So there is no particular. So this question is from Isibo Ikwegbe. I'm sorry if I didn't pronounce this right. So there is no particular error value for you to realize that okay, at this junction my model is at optimal. You just need to keep improving the model, and the lower your error value, the better your model. So say for instance you've gotten probably like we said 160 60 something, then the next model gives you around 100. So definitely you know that new model is far better than the previous model that you created. Okay, so how do we retain? So I think this person means retrain. So it's very simple. The same process that you went through. So this question is from Abdijalil. So the same process we went through from here, from the one-off encoding up to you splitting the model, then you creating the model. So the same process we went through from the one out encoding, which is the PD dot get dummies, straight down to you evaluating your model. That's how you retrain your model. So once you know your model is okay, this is not performing as I want. Maybe I might need to just remove probably the day of the week. If I remove the day of the week, it could get better. Then you can also remove the day of the week column and try to retrain using the same process. Okay. So where are we? Mechanism to change in a bit to retrain the model. Okay. Sorry. I think we have a lot of questions here that I didn't capture. So from first does it do it says the random state has what function? So there's no particular function to random state. Random state is just for you to keep your splitting in check. So apparently you are splitting randomly, but you need the same set of splitting that you did earlier. So you need to set a random state. So if I'm using zero as my random state now, if I'm going to retrain the model again, I'll have to use zero again just for me to retain the size, sorry, the pattern of splitting. Okay, I'm trying to see if I can get and understand. So okay, I like to use something that is very, very relatable. Let's say you're picking beans at home. You're trying to pick this from the shaft. So you can't tell me the way you pick the beans in the first instance is the way I'm going to pick it exactly in the second instance. But random state helps you pick it exactly the way you picked it earlier, even though it's random. Okay, so another question from Isibo again. By retraining the model, you just change the x value. You are not necessarily changing the x value. You have a lot of x values there. So one x is a feature. Um, Let me show you other examples of x values that you have here. So these are your x values: total view, gender, smoker, day, time, and size. So you are not just changing them; you are just tweaking them just to improve your model. Oh, okay, training a model is just your your computer or your machine trying to learn the pattern in your model. So let me try to explain again. So from Ibanga ebook. So in case you are talking about this particular cell. So for you to train your model, you need to import the library that you want to use. So the library I'm using here is linear regression. So I'm importing it from linear model in SQL. So after importing your linear regression library that you like to use, then you need to instantiate your model. So that's just basically you turning your model on. It's like you want to drive your car, but you need to turn it on before you drive your car. So once you instantiate your model, then you can now fit your data in the model. So after fitting, when the model has learned from your data, then you can predict. Okay, so please, how do we give conclusion on the model? What can we deduce from the result of the model? This from Tony Ade Shoba. Ade Soba. So how do we give conclusion on the model? What can we deduce from the result of the model? So you can give conclusion from the model with your evaluation metric. So after creating your model and after training your model and testing your model, this is your root mean squared error. So when you test another one, when you create another one and you test another model and you have lesser or a higher RMSE, which is a root mean squared error, then you can compare it with this and tell us which one actually works better than the other. Okay, change of test size. So you can change your test size from so you're talking about the change of test size. So you can change your test size from here. And then you can change your test size from From here, so this simply means you are using 20% of your data to test, while you are using the 80% to train. But it's preferable for you to have larger percentage to train. So if you want to, then you must not have too much so that it won't overfit. So you can decide to change your test size to 0.3. So that's you using 70% of your data size to train your data, then 30% to test. I guess that's all. So for the data sets, you can, Abdul Malik, you can go through the Google Classroom for the data set. Line 37. Okay. So line 37 is just describing your label or your target variable. So what I did on line 37 is just to show you the minimum amount of tip that is being given by the customers and the highest amount, which is some customers might decide not to give anything at all, and some might decide to give as high as 1090. So from investors, 80/20 is one of the best option. So your tip is your target variable, is what you're trying to predict, like what what will be the amount of tip that this particular customer will probably give the server. So that's what we've been trying to predict since. Okay, this is a prediction model. It's a linear regression, so it's a prediction model. Oh wow. Okay, it can be done using SPSS as a starter, but not in this case. We have more focus on Python here for machine learning. But linear regression can be carried out on SPSS or Stata, but you can't predict on SPSS or Stata. Do you have any questions? People in house? Or how far with the model? Is it making sense? Are you trying to solve it here or you want to take it to? I just explained. The lower your RMSE, root mean squared error. So your root mean squared error was gotten from mean squared error. Just the square root of your mean squared error will give you your root mean squared error. So the lower the root mean squared error, the better your model. Yeah, it's better than what we just solved. So it has to be as close as it can get to zero. You can also try to just attempt it here, rather than you just going home and running the same library. Sorry, the same notebook. Okay, again, error is asking why didn't I use MAE? That means absolute error. You can use either of the two, either mean squared error or the mean absolute error. But for regression purpose, most times we use this mean squared error. That's the mean squared error. But you can also use mean absolute error. And also note that the lower your mean absolute error, the better your model. Okay, so you don't need to be scared as one. And you don't need to be worried, but this is a beginner class. So this is the foundation. You just need to, I think you just need to understand your steps more. Even if you're not getting the syntax, coding syntax right, you need to know what you are doing. So you can always get this coding syntax on Google and the likes. But if you don't know what you are doing, that's a bigger problem. And I think everything has been explained here. It has been explained here. Um, okay. So this is just basically what we did. So the data has been collected. Data has been collected, so we don't need to probably go to the field or ask someone to fill a questionnaire or go to Mama T's restaurant to get the data set. It has been collected from for us. So we started from the data preparation to the analysis and evaluation. So for the data preparation, we did the ED, which is the exploratory data analysis, which was what we did here, trying to understand our data by visualizing the data here. Okay, from here. Okay, so you understand the pre-processing stage. Oh, okay, yeah. Me. Okay. Okay, so let me take it from here again. So you understand to the point of me splitting our data set here. Eh? So after splitting your data set, so the large chunk of the data set which you want the computer to learn is what you are putting into your model. So what we are doing here basically is just training our model, creating a model. So this is the first model that we'll be creating. So and to get the model, to create a model from scratch, you need to import the library, which is linear regression. Now you've decided that you want to use linear regression because it's a continuous data and it's a supervised learning. So you want to use linear regression. So now that so on this first line, you imported linear regression from sklearn.linear model. Then this second line is more like you are starting your regression model, the linear regression itself. Now you're putting it in motion. Like I explained earlier, if you let's say you want to go out and you need to use your car, you don't just jump into your car and move your car. You need to start the car. So you are starting your model here. So you can also say you are instantiating the model. Then after starting the model, then this same model, because this particular line has been stored in this model variable. So you are now training your model on this next line. So you are using your X train and your Y train. So your X train are the features that you want to use to predict your Y train. So you are using both of them to train your to train your model, which is fitting. Whenever you're fitting your model, you're training the model. So after training, you need to now predict. So now for prediction, we are using X test. Now for prediction, you won't need Y train because what Y train is what we are doing here is just training the model. Like the machine itself is getting to know the model, so it has to know the in and out. So here you want to know how best it has performed. So you need to run your predict with this X test. So after running the predict with this X test, and what we just did is just to visualize the first 10 predictions. This is from 0 to 10. So so once we've gotten our predictions, which is model does predict X test, we store this in prediction. So we need to compare what we have, what we've gotten now versus what we have earlier. So which was what we did here by putting them in a data frame. You know what a data frame is? So it's like putting them in a table. So when we put them in a table together, so we said our white test should be called actual values and our predictions should be called prediction using dictionary data frame. So then we store this inside comparison. So we just get the shape of the comparison, just know how the data looks like. So now from this shape, I can tell you the data has 149 rows and 2 columns. And we need to view the first 30 rows. So now, viewing the first 30 rows of comparison, remember that we have the actual value and the prediction. The actual value was from Y test that we saved earlier. So we have them beside each other just for you to compare what you got and what you have. So then we calculated the error between them. So that's just 436 minus 290.2 something something. So that's the error that we got here. So this is just for this is just for proper calculation, just normal calculation. Let's get here. So now, so after creating the model and creating your prediction, then we now evaluate the model, which is what was going on here, using root mean squared. And root mean squared is the square root of mean square error. So we got the mean square error by comparing the Y test and Y prediction. So you have your Y test that you have from your data set which is created, then the prediction you got from your training, from the model that you trained. Then you printed it out with 3 decimal place and you looked for the square root of mean square, which is numpy dot square root of mean square. Then you also printed it out in 3 decimal place. So if you try to calculate the square root of this, you get this. And try it. So that's all. Does it make sense now? Does it make sense? We have 7 minutes more. Okay. Okay, so I can't. Okay. I'll give you an instance. So for sorry, Isibo asked for an example by changing necessary data in order to reduce the RMS. So because of our time, which is running out now, I'll just give you an instance. So once you get them and you run this and you got whatever it is that you've gotten as your gross mean squared error, and you would like to reduce the error. So one of the few things you can do is to drop one of these gender after you've gotten the domains. You can drop one of the gender because you are still saying the same thing. So if it's not a female, you're a male, and if you are not, and if you're a female, you cannot be a male. So you can drop one of these gender. You can drop one of the small cons also, and you can drop just one of the days of the week, and you can also drop one of the time. You can drop one each from the categorical variables after you've gotten the dummies. So and I believe your model will improve. If you use that same data set after dropping them, the model should improve. Okay, Ganiat, if you are not getting it, I guess you just need to practice. Because if you don't practice, you don't know where you are missing it. You just need to practice. Practice makes perfection. Okay, first of all, we said checking the correlation of each feature against the target variable. Why did the number of rows reduce as against the original number of rows in the data set? So I don't understand this question. So maybe you can advise. So can we have access to material? Yes, you can, and you will after the class. Please, can you explain the dummy table again? So the dummy table is just us trying to restructure what we have here. So the computer, let's say the machine does not understand male or female. No and yes, Thursday, Sunday, it does not understand that. But if you give it but if you can change the data into zeros and one, it definitely understands better. So that's why we use the dummy. So the dummy is replacing the male. So that's why you see what's it called? For male, you have one and zero, which one is for male and zero is you're not the male. Then you have to bring another subcategory alpha under gender female. So zero, you're not a female, then one you're a female. Smoker, same thing. Yeah. Mhm. So, okay, the original number of rows in the data set is 744, but after training the model, the number of rows reduced to. So that means, Festus, you didn't get it. So, okay, we have the total number of rows as 744, but the data set has been splitted. If you could remember, if you could recall from here, sorry. So the data set has been splitted here. So we've used 80% of the data set, which is 0.8, to train the data, then 20% to test the data. So you can't have all your data together again. So if you had both together, which is the 147 that has been used to test with the ones that have been used to train, you have a 744. For me, you have to catch up. I think the recording will be available and the notebook will be available also. Okay, so is this something we can try and do? Is that? 9:30. Yeah. Okay. For line 30, we are just splitting your data set, the whole 744 data set. Now we need to split it. We need to use some of it to test if our model is actually correct, if it's making sense. So what we did here is just split it into X train, X test, Y train, Y test. Then we use our train test split library that we imported. Use our train test split library that we imported by splitting the X and Y. And our test size is 0.2. That's 20% of the whole data set. So that's 20% of 744. then we maintain a random state to be 42. Now, if I remove these random states, it's not the same set of data that was used to test earlier that I will get if I'm to do it again. So this random state is more like, okay, I just want to use an example that you relate to very well. Have you tried pushing a car before? Okay. If you probably if you probably block or choke one of the tires with a stone, you know the car won't be able to move. So that's what you're doing with these random states. So you need that same set of data, but it's going to be random. Like I explained earlier, when you're trying to pick a beans, oh sorry, set of beans. So the fact that you picked it at first doesn't mean you're going to pick the same set that you picked at once. So using random states and a particular value, so whatever value you use here, if you are doing it again, just use the same value, you have the same set. Why is yeah, we would like to test, but at the same time, we do not need much to test. It's just like you cooking and you're trying to taste your soup. You're not going to what's it called, take large chunk of the soup. You just need to taste a bit, just for you to know if it's okay or not. No, no, it doesn't matter if the data set is larger. Once you're using the 20%, it's just going to split it into 20%. And like I said earlier, you can use different range, but you just need your training data to be more like way bigger. So you can use 0.25, which is the 25%. Some use 0.3, which is 30%. But I don't think I've seen anyone that intentionally use more than 30%. You can change the value to any value that you want. I can decide to change it to 116. But you notice a change in my model now. Now that I've changed the value. Okay, so do you remember the value that was there earlier? Maybe 280 something that's changed. So say my RMSC will also change. So now this model is better than the previous one that I did. Why? Yes, to an extent, just to an extent, but it won't leave a certain range. So it might not be more than 130 to 170. And if you probably tweak your features, your data set, you get maybe as low as 80 something. So if I change this again, that value is still going to change. So you can just give me any random state number. Just suggest a number. 200. But if I keep using this 200, I'll still keep on guessing. Okay, before I run it, so we have 390 here. I want you to take note of this value. So you can see that it has changed. So if we run our RMSC now, which is this, we have 160 this time around. So it's still within that range. Okay. I think our time is fast spent. I don't know. Maybe we can still continue since they are not chasing us. Okay. Yeah, continue. Okay. There will definitely be a lot of factors. It's going to be supervised. Why? Because you're trying to learn from, okay, they've been winning matches in the past or they've been losing in the past. So, okay, maybe you are now trying to predict if Man U will win because of Chelsea. That can be association. No, that's still that's still supervised. Yeah, yeah, but that's still supervised because you're still talking about Chelsea's zone. Now that we moved to sport, so you're still talking about Chelsea's zone. Or maybe I didn't get your question. Exactly. Yeah, it's still supervised. So if you are talking about another team entirely and it's not Chelsea, so that's like in association with Chelsea. That's association. Yeah, still dependent on him. No, whatever value you have, whatever it is you're predicting there, it's based on everything about him. Maybe it's coming from home, it's coming from the stationery. Yeah, another entity entirely. Reinforcement. Okay. So I believe you would have seen robots, at least if not in real life, in movies. Yeah, the way robots moves when they get to, okay, now let me use robot. Let me use a newborn baby. A newborn baby learn how to walk, right? And learn how to probably talk or something. So when it starts learning how to walk, once it stands up and it couldn't stand up very well, and the baby couldn't stand up very well, the baby falls. So that's a penalized, that's a was a penalty for not being able to do it right. But if you could do it right, you clap for the baby, right? So that's was a reinforcement. So there will be reward and there will be penalty. Does it make sense? Okay, let me just check here for the RMS reduced a bit. Yes, it reduced because I changed the what's the name? Random states. So why is maximum tip still the same from a banker? So maximum tip is still the same because it's part of the data set. You got the maximum tip from the data set. It's like you went to the canteen and you asked for everything that they have. So it's not something that we've changed ourselves. Yes, of course, linear regression have hyperparameter tuning, but we are not getting into that yet. Shit. Yeah. Okay. Because this is a beginner class, we cannot use label encoder yet. Now, yeah, hopefully. So you can't just get there now. But label encoder, one not encoder still works like this, but there's just one or two tweaks to it. Yeah, you know how important that variable is. Okay, maybe if I use this variable, if I multiply it or use it in relationship with another variable in the system, will it improve my model? So you want to model the try. So that you are Okay. Babasile will share the notebook with you. Okay, so let me just check the oh and ask and ask. Okay, so do we have any question? Okay, the total, total. Yeah. Okay. So standardization is also part of it. It's also part of what you can do. So standardization is just to remove irregularities amongst the data. So take for instance, you have 2,125 here, you're having 3,000 here. So example of standardization is just for you to find a log. So you know once you find a log, it's between 0 and 1. What is the total negative? Better. So you need to be aware of your case study before you choose this type of standardization. We have many ones, we might say that we have different types of standardization. So to have a better idea, you don't expect the total bill to be negative, do you? In your opinion, you're not giving the money and your face positive. So it needs to be reason. Yes, yes. And also, like, this actually what we are here. They still need to be smart. So use your but that's a great effort actually. Okay. So if you want to practice on what we advise, just you can practice on your own. You can always practice on your own. And if you encounter error, or if you got stuck, you can always reach out to the team, be available. Then how can we access the notebook? It should be shared. It should be shared now. Okay. So any other question? Project. What? Yeah. I just need to see difference. Like, how about yeah, yeah. Exactly. Yeah. Improvements is just you pre-processing, going through the pre-process and pre-processing and getting to the model, get a value. Okay, maybe this is better. How can I improve it? Eventually, you get to a certain flow where you can no longer significantly improve it. So that's where you know, okay, yes, this is way better. So do you have any other question? Oh, to the beginning of the code. Okay, so there are no questions. I think we can call it a day, right? For those online or offline. Offline. Is it for those online or offline? Offline. I think you did you scan your phone when you enter? You didn't scan, then you have to. Okay, so here's the attendance. I think set of questions as marks the end of the class, right? So we can now try this at home. Um, Matplotlib. So Matplotlib is just basically used to visualize your data whenever you're doing visualization. So this is somewhere John uses said, can we get a recap of this Matplotlib? So it's a library used to visualize your data. When you're trying to create a visualization, it's a Matplotlib in Python. The pandas profiling, do we have to install the packages before importing? So you don't need to install pandas before importing. All has been installed for you. If you are using an Apanda, it has been installed. Unless, and I don't think anyone of you is using Python from scratch here. Yeah. Are you? Are you using VS Code? Are you using Jupyter Notebook? Yeah, so you don't need to install pandas. As long as you are using Jupyter Notebook. Using okay. Panda install. Don't worry yourself about Panda install. That's profile report do. So hello. Okay, what does profile reports do? Okay, it just basically gives you the summary of the data, just like the way you have described. It's more detailed. Yeah, you have to make sure it's ticked on the Anaconda. If not, sometimes it's not automatic. So, unless you tamper with your Anaconda and your digital, I'm very, very sure Pandas come with everything. Okay, Pandas profiling. Yeah, it might be. So, in absence of question, this has been an eventful afternoon. Thank you once again. See you in tomorrow. Right, bye.